What else do we have here? Okay, now we're switching over towards focusing on the interest rate. So beforehand, I focused on the multiplier process. We are pretty much done with that now. You hopefully all understood what that means, right? Basically, the second round effects by initial shocks. And now we're focusing on the interest rates. So the new thing here was that we say real investment, so business activity is a function of how business is normally doing, how the GDP is normally doing, but also how the interest rates are. If the interest rates are higher than normal, take a guess. If interest rates are high, is it good for business or bad? Bad, right? So we're talking about real investment, not financial investment. So that's bad for business because financing is more expensive. Hence, we've got a minus sign here. And B is showing us the sensitivity, how strong that impact of the real interest rates are. And the whole thing is multiplied by GDP just to show that the impact on large economy is, of course, $1 million larger than in small economies, right? Or now, the impact of an interest rate change in millions of dollars is larger now in Australia than it would have been 100 years ago, because 100 years ago, everything was smaller in Australia. That's the whole point why we're multiplying this one with Y. Plus, later down the track, a few slides down, you will see actually makes our life much easier too, even though it looks more complicated now. So for now, I want you to focus on R and investment. They call this little r here marginal product of capital. Just think of that one as normal long-term real interest rates. I think that's good enough. So again, this one, just as before, we had deviation from normal GDP. We've got now deviation from normal interest rates level. Good. So now we need a second graph down here. And remember, I think I did that once with the Solo model too. Sometimes it's important to have the graphs aligned in a certain way. So here we've got them aligned on top of each other because we've got here GDP and here GDP. So when it's here, let's say 50, it needs to be here 50 as well. If it's here 100, it's here 100 too. So it's important that they're 100% aligned with each other. Otherwise, we can't do this. So what's the idea here? We've got the aggregate demand. Let's start with this one here. That's the initial aggregate demand function, this whole big shebang. And we're not interested in anything apart from the interest rate. And I let the interest rate go from the initial interest rate here, and I let it drop to R1. So R1 is a smaller interest rate than R0. If we drop the interest rates, business is going to be happy, and they do more real investments, so they're going to do more projects, more buying of machinery, etc. So investment is going up, and since investment is part of the aggregate demand function, aggregate demand goes up, and we know on the equal sign here, that means GDP goes up, and the whole multiplier process happens again, right, until we are in a new equilibrium here. So that's in the top graph. Lower interest rates means higher aggregate demand, more GDP activity. But we can plot that also into the lower graph here. So let's say the old equilibrium was at R0. I just take anything that I want. R0 is here. So at R0, this was the old equilibrium. GDP 0. And now if I decreased R, so pick a lower R here, let's say I decreased R by half, so I'll go down here. For this lower R, our GDP is higher over here, so I can plot that over here. Let's say, well, let's make it clean. So you can see why it's so important to align these things. So we've got the new equilibrium here, lower interest rates, higher GDP. And you can imagine I can do that for all kinds of R's, right? So I can drop R even further. Then I would go lower here. Aggregate demand would go up here. And I would get a new equilibrium somewhere up here, which means I can plot it down here, and so on. Basically, I can do it such a way that we get a new curve. So if I do that for all kinds of interest rates, we get a curve that is running through these points. And on this curve, what we did is we changed the interest rate. and we looked how does the interest rate affect GDP after all the multiplier stuff happened already. So all potential crossing points with all potential aggregate demand lines here for different interest rates. Make sense? So we didn't change the equation, we just sliced it in a different way. We looked at it from a different angle, right? So you can imagine, you can look at this piece of paper this way. Then it looks a certain way, maybe long and wide. But if I flip it around, now it looks very narrow. It's the same paper, just as this one is the same equation here. Down here, I didn't change the equation, I just changed the dimensions. We're still using the same equations. So it's showing us in the graph basically all combinations of interest rates, so any kind of interest rate that is giving us an equilibrium between aggregate demand and GDP, and therefore a certain amount of GDP. All the combinations between R and GDP where we have this in equilibrium, aggregate demand equals GDP. And by the way, it might be worth writing that down here too. That is the so-called goods market equilibrium, because we're talking about everything that has been produced, all the goods that we're producing are also going to be either consumed, used as investment, or exported minus imported. So that's our good market equilibrium. We will have plenty of different markets in a graph here. We can do the same thing in math as well, right? So that comes over here. So it's the same game as before, blah, blah, blah. Again, I put in the same arrows as beforehand, minus, minus, minus. And we had here minus, minus as well. You will later see, I think they disappear anyway. That's the reason why I didn't notice. Good, so we can write down this equation. And this equation says, well, there's a link between GDP and R, and the link between the two has a negative slope. Just as this thing here has a negative slope. Basically, the math equation behind this one is this thing here. Now, be a little bit careful with the slope. B. What do you imagine? If B is fairly large, would that mean that R has a large impact or a small impact on GDP? Just try economic intuition first before you try the math. If B is large, does it look like GDP would be affected strongly or little? Where is it? I don't know where it came from first. Nobody wants to say it? I'll make another question in a second, but strongly, right? Strongly. Now, just say the first thing that comes into your mind. If it's affecting strongly, how should the slope look like? Steep or shallow? Steep, right? False, unfortunately, right? So why is that false? A strong impact on GDP. GDP is down on this axis, not on that axis. It's 90-degree twisted, right? You're used to write y as a function of x, right? So you would be used to write r equals something with y. But here it's y equals something with r. So it's twisted by 90 degrees. This is when you make a graph, y on the, I think it's abscissa, and r on the ordinate, on the x-axis, right? So it's just flipped by 90 degrees. And the way to get around that one is, well, you could flip around all the math. That would be a nightmare. Don't do that, right? So just use your economic intuition. You already all said by economic intuition, if I change r a little bit and b is large, GDP will change a lot. Just take the logic over to your graph. You change r a tiny bit and large GDP changes. And now the slope is shallow, right? Easy as that. Or if you don't like that, just twist the graph by 90 degrees, draw it in then, and then twist it back. But I think that's the easiest way, right? Little r changes, big impact on GDP. That would be a large B, and the other way around too. Small b, small changes. Good. Got that, got that. So that's a famous IS curve that we will play around a little bit. By the way, IS curve is still relevant for the exam. I just do some basic stuff. Basically, how much of a hint should I give? Microphone is on. So for sure, you need to know when it's shifting and when you're running along. That's what we're playing around, a little bit around now, too, with as well. and some of the basics. So you don't need to do all the math in the exam for this one. What else do we have here? Blah, 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 blah. That's out of your reading. I'll let you just read it again quickly. So let's see, we've got two things in here. Oops. If you just look at that highlight, which graph would be affected by that sentence, or in which graph could we depict this? And just raise your hand that I can see where it's coming from. You are first. The IS curve, exactly right. And how would the IS curve look like in this case?
If lowering the interest rates isn't going to have much effect on the GDP, then in that case the growth would be quite
Yes, spot on, right? So this one describes a situation where the IS curve is very, very steep. So if the IS curve is very steep, I'll come up there in a second. So just imagine an almost vertical IS curve. Right? So businesses are so negative about the future, they don't care what the interest rate is. So they hardly affect, even if you drop the interest rate by quite a lot, there's hardly any impact on the business decision. Very steep IS curve. And on top of that, we can say something else too. So they said here, everyone tries to hold on more money. How does that relate to our model? Let's say the government is increasing its expenditure, G goes up a little bit, but if everybody is trying to hold onto money, different word for holding onto money is?
So there's consumer expenditures decreasing, so to incentivize that, they decrease rates.
Yes, it's realistic that they're decreasing, but say it's slightly, if you want to see it in the model. Where's a good way to see that one? Here, right? So if you say consumer behavior is decreasing because they're pessimistic, and that's true, that would be this part here is going down. That would be an autonomous change, not really in the model itself, so we just plonk onto, which makes sense, right? It says here from the outside, consumers are very pessimistic. But I'm after something slightly different. If you're giving them additional income because the government is spending, but they hold on to that one, where do we see this in this equation? X, and it's going to be exactly 0, right? Good. So that means even if you give them more money, there's no additional spending here. But I can see where your one is coming from, because they were talking about a recession where income is going down, and you were thinking they're cutting their consumption by a lot. So I can see why you would have set 1 there in that moment. Sounds a bit like a contradiction too. Our model is too simple for this one. In order to solve that contradiction, you need 2 multipliers. 1 multiplier for positive shocks, 1 multiplier for negative shocks. We clearly don't do that in this class. Then the equation would become even more complicated. But that would be a way to solve the conundrum that we just stepped into. And I didn't see that coming. That was a good point. Good. You have to remember, these are, even though they look complicated, they're still baby models, right? We keep it as simple as possible. They don't cover everything. Good. Where was I? Got this one all done. Done. I'll come around in a second. Good. So steep IS curve and the aggregate demand curve, I would argue in this moment, potentially fairly flat, so we don't have a positive multiplier here anymore. Good. Let me see on with time. I'll do a tiny bit. Let me see how much more I want to do. I want to go up to this graph, and then we do a break. So I talked about absolute GDP and potential GDP. Basically, we were talking about millions and billions of dollars. But last time I already introduced the GDP tilde here, and that was basically the percentage difference to our potential GDP. That was a little bit complicated. There's an equation for that one in a second too, if you've forgotten it. So there's some good news. What we basically do is we just scaling it. So we're dividing all our equations by potential GDP. So instead of aggregate demand in billions of dollars, we get aggregate demand in percent of potential GDP. So we can see, is our economy running at 100% or 50% or 120%? So in the graph, we would just shift everything, and everything would be a little bit like the log scale would go onto a different scale. Instead of billions of dollars, everything becomes percentage now. And then we do a second trick. We subtract 1 from all the equations on both sides. And in the graph, that means that something that was beforehand 100%, if you're subtracting 1 or 100%, now becomes 0. So basically, we do 2 steps. Number 1, we shrink the whole economy away from billions of dollars towards percentage. Number 2, we shift the whole thing towards the left so that we are focusing on the 0 point, because we are interested in, is the economy positively deviating from its normal running or negatively deviating from its normal position. That's what we're after. So the graphs basically look all the same, and the economic intuition is exactly the same as we did beforehand. So the shocker here is math looks a bit tough, but we just do it once to understand what's going on, and then you can kind of forget about it again, as long as you understand the final result, the final equation that comes out of this. Good, so typical error here, because this is also paste and copy job for me. Minus imports, minus AIM, minus AIM. I'll fix that later after class and put the new slides up too. So these need to be all minus. And then the other error, did I do that here too with the X? No, wonderful. Here the error doesn't show up because of that trick. That's the reason why I didn't realize that. Very good. Maybe. So, step by step. This is exactly the equation from above. I just copied it over. First step is we divide everything by potential GDP. So now everything becomes percentage. This one becomes actual consumption as percentage of GDP. So here, divided by Y bar, just disappears Y bar, AC remains. This thing here divided by Y bar becomes this one. And I go one step further. This one looks somewhat familiar. Actual GDP minus potential GDP divided by potential GDP is just our Y tilde. Right? So it looks complicated, it actually becomes much simpler in a second. Here the same thing. Here outside of the brackets we have times potential GDP, dividing everything by potential GDP, just the edgy brackets remain. And now we have here the investment to potential GDP ratio, is this thing. And here we have government expenditure divided by potential GDP, it's just our, let's say, government expenditure ratio, export ratio minus import ratio. And here one of the reasons why they call this A is, and A bars, now you can see here beforehand, G was growing potentially over time. So over time, GDP is growing, and the government is usually growing with GDP as well, so we couldn't make these beforehand bars, right, because these were changing. But it seems quite reasonable to think that in normal times, the government has a certain fraction of GDP in expenditure. So the government is not going in percentage towards 0, and it's not always also going towards 100%. In the US, it's around 20%. I think in Australia, Germany, countries where the government is a little bit more active, it's going more towards 30% of GDP is government expenditure. And that's a somewhat stable number. It might be 27, might be 35, right? Going up and down, but it's certainly not going towards 100 or towards 0. And that's what we're assuming here. So in normal times, this is just a stable percentage number. That's the reason why it's got bar. Same for exports, same for imports. Good. And we call these autonomous because we put them exogenously into the model. We can play around with them, but they're not explained in the model. They're coming from outside. So then we are at this equation here. That's the same as that one. And now we subtract minus 1 from both sides, or minus 100%. So we're just shifting it so that our corner point is 0, and we do this here. You can see it here already if you have -1 here, and if you have equilibrium, this one becomes GDP, then this thing here is again y tilde. That's the reason why we're doing this. Here we've got the y tilde already, minus, and here's the -1 just added on. Now I copy this thing over to the next slide. It's here, and I make it bold the things that we're interested in. We're interested in y tilde, our GDP gap in percentage. That's written down here now. And we are interested in impacts on R, the same as beforehand. And I think, do we do this one after the break? That seems reasonable, right? So you get a little bit of a breather, can collect yourself again, and then after the break we continue straight away with the U-turn part. Good. So U-turn, it says, how big is YT if the economy is at its potential? That's a quick one, hopefully. If the economy is running normal as its potential, y tilde is exactly 0. Very good, right? So if we are at the normal case here, this would be 0, right? Remember how I said we do everything in percentage and then shift it? So that's 0. I'll come back there in a second. How does aggregate demand change if you increase YT? So let's see here. If okay, it's a bit of a trick question. Very good. So if I increase YT, how does aggregate demand change? Does aggregate demand get bigger if the economy is booming? Aggregate demand is getting bigger or smaller or equal? Bigger. Everybody's on board is bigger. Very good. Now the catch question: shifting the line or staying on the line? Staying on the line, and why? Why do we stay on the line? Yes, right, because it's the variable down here that I changed in my question, right? If I change something here, it means I'm staying on the line, because the whole point of that equation and the whole point of that line is we drew aggregate demand for different y tildes here. So if y tilde is very, very negative here, aggregate demand is very small. If we increase it a little bit, it gets bigger, 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 bigger. That's the whole point of that equation and that graph, right? Changing y tilde. Good. How does aggregate demand change if you increase R? Interest rates up. Just look at the signs in front of it. What happens to aggregate demand? Decreases. And this time shift or running along? Shift, right? Because R is not on the graph here. Very good. So pretty much the same as beforehand. I hope you can see that. So the logic is exactly the same as beforehand. Everything remains the same, just now that we're talking about percentage distance from normal. So I copied that thing over from beforehand. Remember the -1 here. Remember also this one needs to be minus here. Imports minus. Oh, look at that magic trick. Here's a minus all of a sudden. Don't know how I managed that one. Good. Bringing all the y tildes over to the one side because we want to solve for that one. So we have these here. Again, do the same thing as beforehand. We can bracket the 1 minus x out, or the y tilde out, and divide both sides by 1 minus x. Gets this one. And now you can see why we did it so complicated beforehand with the autonomous percentage government expenditure, autonomous percentage consumption expenditure, autonomous percentage of investment expenditure, because all of them are now constants, and we can just put them all together as one variable, a bar. And there's also the -1 in here. So the whole thing becomes nice and easy, this very simple equation. And that very simple equation is basically condensed everything that we have done over the last 60 minutes. It's the same equation, just written in a different way. So when I tell you, for example, exports are increasing, exports are hidden in which variable here? Autonomous change in export? A bar, exactly, right? So it's just, remember here, export percentage, it's part of a bar. So whatever shocks I'm giving you, anything that is different from GDP or interest rate shocks is basically hidden in the a bar. Just that we have the multiplier separate, so the multiplier was the savings, basically, marginal propensity to consume, and B, the interest rate sensitivity we are interested in as well. But all the other shocks, something happens in China, something happens in Germany, Consumers are getting more pessimistic. Investors are getting more positive. All that stuff is hidden in a bar. The only thing you have to figure out is it up or down. Any positive shock is up, any negative shock is down. There is something else to it. Let's say, for example, the economy is in its long run equilibrium. If we are in the long run equilibrium, everything is on the balanced growth path, the economy is running normally. Number one, how big is our y tilde? Everybody should know that now. The economy is running at its potential. Y tilde is exactly 0, right? That's straightforward. Also here, what's the difference between normal interest rates and interest rates at the time if everything is normal? 0, that flies out too. So that leaves us with a bar times 1 over this thing, right? So the multiplier is not 0 because we multiply, we just put in exogenously in. So if the left-hand side is 0, and here we've got only now a times the multiplier, what does it imply for a in normal times? A must be 0. And that's a quite nice thing about this equation, right? That means if everything is normal, if we don't have any specific shocks, A is simply 0. And on the other side, if we have any kind of shock to the system, global financial crisis, more government expenditure, better tax system, anything that's shocking the economy will change A. So you can see we ended up with a very, very simple condensed equation, but that is giving us pretty much all that we need to know for now. Good. I think this is pretty much everything that I said. Blah, blah, blah. Yes. A, autonomous aggregate demand shock. So if there's no shock, then A hat is simply 0. Good, we got that covered. Here I've done the same as beforehand. So here we've got the standard aggregate demand. There's just copy and paste job. And now here the same trick as before. If we're changing R, aggregate demand is changing. Let's say, for example, we again decrease the interest rate. That means people are happy to invest more. And here there's no interest rates on the graph. That means on this graph it's going to be a shift, right? Up here, changes in R shift the aggregate demand curve. Lower R means more aggregate demand. For example, to here. We get a new equilibrium point that we can plot down here. Remember, I started with lower R, new point here. And I connect all the dots for all the potential different R's, get that line. And here we can see even in the math, nice, much cleaner where the line is. Recall again that R and Y are kind of switched around in the equation. But you can see here it's a linear equation with a slope of minus B. Remember, it's 90 degrees, so actually the slope in this diagram is minus 1 over B, but don't get stressed by that. Right? It's just a 90-degree switch. Good. This is the rule of thumb that we already covered beforehand, but lots of exclamation marks, so that will be not only important in this class, this is something that you will see in lots of classes. Whenever you do anything with math and graphs, this is a useful rule of thumb, right? If you're changing one of the variables that is written on the axis, running along. If you change a variable that is not written on the axis, it's either a shift or nothing is happening at all. And I think now finally I come to one where it's your turn again. I can go around, spread these a bit. Let's make that, I think you can cover that in 5 minutes. That's pretty straightforward. So your job is basically to figure out all these shocks here, how are they affecting our IS curve. How are things going? Good. So I always like it when you're chatting a lot. That means they're thinking about things and talking. That's good. Let's do it together. Germans switched from petrol to diesel car. What's the impact on Australia? Suggestions? Just throw it in. Nothing, right? So don't feel the push that you always have to have an impact. Certain things simply don't have an impact, right? So in this case, there is simply no impact. We don't have to shift anything. There's no running along. for the exam, so this is not in the exam, but just in case if you're in the exam and you don't know for sure, instead of just writing shifts to left, shifts to right, or nothing, just write a mini explanation what's going on. Because maybe you're thinking, switch from diesel, maybe thinking, well, because Australia is a major diesel exporter, this will be good for our exports. Not true, but at least your economic reasoning is good, and you would get 4 points for that too, right? So the point is reasoning, right? I'm testing your economics here, not your detailed knowledge about Australian exports, right? So if your economic reasoning is solid, you get partial points. So always write a mini explanation down, just to be safe. Good. More, but here, of course, the answer should be nothing, right? There's a much better answer. More Germans travel to Australia. Anybody an idea? Exports are third, so that's exactly right. So we're exporting services. If people are coming to us in Australia, we are selling them stuff, we are selling them services to foreigners, it's our exports. And since our exports go up, how does that affect our graph here? Shifts, exactly, right? And I saw you shifting up, which is kind of right, but something else is even better. So it's not really shifting up. You mean, are interest rates increasing or is GDP increasing? GDP, right? So it shifts to the right. It looks the same as up here. So it doesn't matter. But imagine if I gave you, for example, a vertical line. Then it would make a difference if you're shifting up or right. So it's just a good habit to think a little bit if it's a right shift or an up shift or left or down shift on these things sometimes. Australia's interest rate increases. So 2 steps. Number 1, good or bad for the economy? Interest rates up. What happens to investments? Down, right? And what happens in our graph? We move to the left along the line, right? So we're not shifting this time because we changed what's written on the graph here. And if you do something on the graph, we are running along, right? Again, just in case, even if I repeat myself, look what's written on the graph, because if I gave you this graph here and I changed the interest rates, now it would be shift, right? So don't remember R is running along and Y is running along and X is shifting. It depends upon what's written on the graph. If I put written down here exports, for example, and we had the export question, then you would be running along a line that is showing something exports as a function of. Right? So the rule of thumb is to look what's written on the graph. Oh, sorry, did we do everything? Interest rates increase. Government increases infrastructure spending. GDP, bigger or smaller? Or step by step, aggregate demand, bigger or smaller? It's too easy, isn't it? So government expenditure up, G up, aggregate demand up. So aggregate demand is moving. If aggregate demand is increasing, GDP is increasing. So for sure, GDP is increasing. In this graph here, it's going to be shift, right? Because G, the initial shock, is not on the graph, so we're shifting to the right. Good, all done. So if you know that stuff, yeah, that's going to be important for the midterm. When to shift and when to run along. Oops. So here, basic story 2. If the economy is running at its potential, Y tilde is simply 0, so there's no boom or recession. And then the interest rate is at its normal level too. That's the thing that's set here. Here's just the step-by-step logic, right? So if you go away from the graph and the math, the logic is the following. If interest rates go up, it's more expensive to borrow. If it's more expensive to borrow, it's bad for real investment because now your less projects are breaking even, or you make less profits on your existing projects. If there's less investment, well, then there's less aggregate demand, less GDP activity, and you're falling below potential. And because we started here with the interest rate move, we are running along the ice curve. That's basically what we did already. Is it okay if I go fast on these things? I feel like it's just partially repeating. Sensitivity of interest rates, remember, even though in the equation it looks like it's going to get steeper, remember it's 90 degrees twisted, right? So just go with the economics. If GDP or investment is more sensitive to interest rates, It means a small change in interest rates, big change in GDP. And GDP is left, right, interest rates up, down. So it means small up, down, large left, right, shallow slope. What else do we have here? Something a little bit thinking outside of the box. So information technology creates an investment boom. So for whatever reason, they are very optimistic. Demand for capital investment goes up at any given interest rates, and that is part of autonomous investment. So investment in this case didn't increase as before and due to interest rate changes, but simply because businesses are more positive. So that's an autonomous shock, and hence we are shifting the IS curve. Right? Don't remember that changes in investment is running along the IS curve. Running along means changes in interest rates. If you have investment changes due for other reasons, we are shifting. Good. So this one was a bit trickier. There's a lot of text. Let me see what I want to highlight here. Ah, yes. That's a bit of a tricky part. So that was in your readings. And we wanted to somehow translate that one into our IS curve graph. Just have a read. I'll highlight in a second what I'm especially after. I think it was two things here. Let me see. So let's see what they're talking about. They're talking about their beliefs about public spending, how strong the impact is on economic activity. So that sounds already suspiciously like the multiplicator. Right? Remember, the multiplicator is if you change anything of the autonomous stuff, times 1 over 1 minus x is the impact on GDP. What else do they say here? They say something about savings, blah, 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 but the main kicker here is, doesn't say something about interest rates, I was hoping. Spending unemployment in another. Yeah, don't worry, it's not going to be all red. So what's the main kicker here? So we wonder how much is the impact of government spending. We already know it has something to do with the multiplicator, but there's a second effect in here too. Let's see what we have here. They talk about the capital markets. They say savings is fixed. So if the government is borrowing lots on the capital market, what will happen to the interest rate? If the government is borrowing a lot, interest rates most likely go up, right? So, sorry, that was not in the text itself, that was implicitly hidden. So, an important message here is government expenditures, that is debt finance, might increase the interest rates. That's an important one. And now we can go back to our IS curve story here. So, let's do this one together. Government expenditure up, just by itself. How would that affect the IS curve? Shift to the right? So that part is good. It's shifting to the right. Let's say we started here. Equals 0. I'll turn it on in a second. Don't worry. So if we increase government expenditures, I have to write it here, G up, aggregate demand up, and my tilde up, and that will be visible like this. So far, so good, right? So it looks like the economy would expand quite a bit, and we would be happy about that one. So let's say happy face. So this is people that think are positive and that the government can have a positive impact. But now comes the second step. They say, well, a side effect of the government intervention might be they're borrowing lots of money. Borrowing lots of money is driving up the interest rates. So driving up the interest rates, how would that look like in this graph? When we're here and the interest rate goes up, a bit repetitive, sliding up, right? And now it depends upon how far we're going. If you're going up to this point here, for example, we would say, well, altogether that was still having a positive impact. But if you're someone like, let's say, Milton Friedman, or someone that is very conservative and doesn't believe in the positive impacts on government, what would you argue? Not only do interest rates go up a little bit, but a lot, right? And if you're really against government, you could argue, well, they might go up so much that even though you have that right shift due to government expenditure, now the negative impact of rising interest rates is causing GDP to fall, which is a bit of an extreme case, right? Most economists would be between these spots somewhere. Really positive, not positive economists, but economists that are a strong believer in positive government interventions, maybe associated to more Keynesian economists, would think like, well, interest rates are most likely not affecting that much, while economists that are much more conservative would think, nah, there might be major impact on interest rates. Keyword here, I'll do that in later classes, but it fits nicely in here because we just had that in this article. Crowding out. So crowding out basically means, just imagine in this classroom, if this classroom was packed and you squeeze in more people in one door, people on the other door are being squeezed out, right? Same thing here. So if the government is spending more and is more being active in the economy, it squishes out private investment and private activity. So, and the mechanism that works behind it is rising interest rates. So if the government is borrowing more, it raises interest rates, and that makes private investment more expensive, and there's less private investment happening. And that's what we see here. So the reduction in GDP when we're running up that curve is reduction in private investment due to higher interest rates.
What about the effect of people reducing consumption or investment now because they expect government to rise tax rates?
Yes, very good point. So that relates to the discussion, the advanced discussion of the multiplier when we talk about the Ricardian equivalence or the lifetime income. That fits in there. In our equation, we didn't have that because what you're basically saying is, let me see how I can do that the best. So don't stress, this is not exam relevant, but it's a good question. And it shows how you can extend these things because all these models are little toy models, and just like Lego, you can change the things that you build with Lego. You can change here too how we're building our toy economy. So we started out with, if I get it out of the top of my head, like this, right? Times potential GDP plus X, and then we had here actual GDP minus potential. So here for us, we focused on the multiplier that was coming in because consumption is a function of GDP. While you said consumption is also a function of excessive government expenditure because people are afraid that in the future taxes might rise. So you would have added basically a term plus consumption, let's call this little, what would be a good vocab for that one? Anticipation is gone. Let's call it future. F for future times, and then we have here, we want to have a negative, right? Negative. Government expenditure right now minus normal government expenditure. So now we had it in here. So if the government expenditure is increasing above normal, people are afraid that in the future taxes will be higher and they will minus cut back on their consumption.
Would it be correct to put that into the bar to see whether like into the net factor?
Depends upon how you want to model it. If you want to model it as explained within the model, so as soon as you change G, it's changing proportionately, then you need to write it down like this. However, if you just want to think outside of the box, don't change the model, and you want to say, well, if this happens, and if there's a one-time drop in consumption, then you can just change this one here too. That's okay. But here it's, of course, now you have to manually change G every time, while here it would be completely included in the model. So that's the difference between exogenous and endogenous. So endogenous variables are explained in the model. So you plonk everything in there, and then you can basically calculate the numbers all by themselves. While exogenous is you've got like buttons that you turn by yourself manually. Right? Good, but good point. So this is basically how economists create bigger and bigger and better fitting models. And you can see here why people argue so much, right? Because depending on what you think, like if you think like that, you would need to use this model and not that model. And of course you get different results, right? Just as people, here you could argue, well, it depends upon the time. For example, right now, interest rates, if you look in the news, high, low, very low, right? So they often talk about zero-bound interest rates nowadays. So in Europe, some interest rates are negative, right? So are you under the impression that people are afraid in Europe that interest rates get too high if the government is increasing their expenditure? I don't think so, right? So that argument wouldn't currently fly in Europe very much. And you could argue, well, it depends upon how the economy is running. If there's plenty of savings around, maybe because in China there's lots of savings and they're happy to buy all these government bonds, well, then there's unlikely to be an impact on interest rates. However, if the opposite is true, if the economy is already booming and everybody's using their finance for their own investment, and now the government comes in and wants to finance too, well, then this might happen. But let's think more advanced for a second too. Sorry, I'm getting off course here, but it's actually quite interesting. Increasing government expenditure, in which situation would that make more sense? If the economy is booming or if you're in recession? Recession, right? So people that talk about increasing government expenditure to help the economy usually don't think about a booming economy. They think about a recession, and in a recession it's somewhat unlikely that you will have much crowding out. Good, but don't stress about crowding out yet. That's not on the slides. It's just was in the reading, fits in nicely here, and we will talk about crowding out in 1 or 2 weeks' time after the midterm. Clearly not important for the midterm, crowding out. Ooh, time's flying. So star, star, star just means this is a bit of a tricky one, right? So what do we have here? New technologies are discovered, all of a sudden we are way more productive. So potential GDP goes up, actual GDP goes up too. Now the solution says there already, but if you don't read the solution, what would your feeling be in that graph here? If you have higher potential GDP, would the graph move to the right, left, or not move at all? Just gut feeling first. Well, I can tell you what I was thinking. I was thinking, yes, that sounds GDP is growing, so things should move to the right. But we are not in a GDP dimension here, but we are in a dimension distance from potential GDP, right? So if potential GDP grows and also actual GDP grows, and they both grow together, nothing is changing in this economy, right? So in this moment here, oops, where am I? Nothing is actually changing because potential GDP is going up with technology, but actual GDP too, so the fraction remains exactly the same as before. Nothing changes. Just a little bit of a tricky one. Good, finally, conclusion. What do we want to get out of this whole shebang? So we were going after this equation here. This equation is basically our IS curve. Right? And the whole point of the IS curve was because investment is sensitive to interest rates, and investment is part of aggregate demand, GDP is sensitive to interest rates. And in our class, we talk about potential distance from potential GDP. So we can say the distance from potential GDP is going to be affected by changes in interest rates. Interest rates are important for us. And we also learned that any shocks are basically depicted here in the A. So it's shifting the IS curve, and interest rate sensitivity was hidden in B. And also behind it was running the multiplicator. And the multiplicator was a function of how much people are saving, or how much are people affecting their consumption due to income changes. Consumption. Yeah, that's fine. Okay. Just why I said this one here, there's different kind of multipliers. You can also have multipliers from exports, multipliers from government, multipliers from investment. We don't do that. We only focus on consumption multipliers, so we keep things nice and simple here.